In our previous example, our cut plane was parallel to the ends of our member. Now if we cut our member at some angle theta as measured from our vertical, we are going to first of all obtain a different value for our average normal stress, and we're going to see the generation of a shear stress. This is indicated in the image below. Our internal reactionary force counteracts our applied load F1. However, we can decompose this into a normal force, R sub n, and a tangential force, R sub t, where the summation of these two forces would equal our internal reactionary force R. Now our average normal stress, sigma, is now due to our normal component of our internal reactionary force, R sub n. And our average shear stress, which we will denote as tau, is now due to this transverse component of our internal reactionary force, R sub t. Now we will define our average shear stress just like we did our average normal stress, where tau average is equal to R sub t per A sub n, and this has units of pascals. Now we have to note the area for which this force acts upon changes. A sub n is no longer equal to A. Rather, it changes by a factor of cosine theta. It's also noted that our shear stress does not exist in a compressive or tensile state. Rather, our value is always going to be positive. Let us look at a very simple application of our shear stress. Let us revisit our steel chain link with the same geometry as shown below. Now we want to determine our average shear stress existing at the interface of the links. That is, we have a link on the left pulling with a force of 750 kilonewtons, and a link on the right pulling with a force of 750 kilonewtons. Thus, the link in the center is going to be experiencing shear along the center line. For us to solve this, we will focus on the interface between these two chains. A force of 750 kilonewtons is acting across the cross-sectional area of our chain link. This is shown in the figure below. Thus, our average shear stress is expressed as follows. Tau average is going to be equal to our transverse component of our internal reactionary force per our shear area. R sub t is simply 750 kilonewtons, and our area is pi d squared per 4. Thus, our average shear stress is 5.92 gigapascals.